Good morning, everyone. So we start the class. This will be our fifth lecture for system analysis and design. Course code CSB 1211. Our today's class content involves block 4 information gathering and block 5 feasibility study. Under block 4 only unit 12 is left, and under block 5 13, 14, 15, 16 we'll try to cover for the today's class. Moving to our objective of our class is understanding and apply structure wait a minute. Understanding and apply structure analysis tool, so as a JFD, data flow diagram, data dictionary, decision tree, and structure index. And second goals evaluate system feasibility using economic, technical, behavioral, and performance criteria, design effective input, output, and user-friendly form interfaces, analyze and select appropriate hardware and software based on requirement and criteria. Understand concept of system maintenance, software evolution, and version control. Apply change management and modern approaches like agile methodology. Develop skill to design, analyze, and maintain efficient and information system. So moving towards our unit 12, as you can see here, about the structure analysis. The definition of structure analysis, let's first understand what is structure analysis. Structure analysis is a system development technique used to analyze system requirements using graphical and logical tools. And next is what it focus on what the system should do, not how. Okay, always remember structure analysis focuses on what system should do, not how. Okay, how is for the engineer, the software engineer who will develop the system. So here you see how the structure have shown for the structure analysis. This is our information gathering tools. First, what it consists of data flow diagram, decision tree, decision table, structure query, and pseudo code. And it tends to, you see, tree, decision table, structure query will go under data organization. Data flow diagram and pseudo code will stay in that place for information, just for information gathering tool. Next, Moving towards data flow diagram, which is also abbreviated as DFD. First, let us know the definition of DFD. It's a graphical representation of the flow of data within the system. Okay. Components. What are the components it has? Is process, data flow, data store, and external entity. Here, the labels of DFD. There are three. Level 0, which is context diagram. Level 1, DFD, and level 2, DFD and beyond. Means 2 and beyond means it will be more connection or connectivity will be shown inside the system, within the system. Now see this. Here, data flow diagram, level 0, which is context, which is also known as context diagram, represent the entire system as one single process. Okay, entire system in a brief way, they will show the flow of data within the system. This is single process showing its interaction with external entities. It will show with external entities. It highlights measure input and output without internal detail. Internal details, they don't show. This flow doesn't show the internal details, just showing the external overview of the flow of data within the external entities. Here you can see, this is an example given, data, railway reservation, passenger, and admin. There will be three sectors: passenger, admin, and rail. For what it happens, it is happening railway reservation. Okay, passenger, what happened? Reservation, it will request. It can request for cancellation. Okay, and it will go here. Up down train info means like how many trains are available on that particular day, particular timing, and reserve cancel info. Like suppose there was no seat and it was waiting list or REC like that, it is will be request after reservation. It will be cancel or reserve based on the availability. So passenger info will take admin passenger info, and reserve or cancel info will take by the admin. Then admin will process the information to the passenger through this ticket info. This is how the process of railway reservation works. This is the data flow diagram, which is also known as the context diagram overview with external entities. Next, level 1 DFD. Level 1 DFD breaks the level 0 process into measure sub-process. Okay, breaks the level 0 process into measure sub-processes, shows internal data flows and data store. So it will show the internal data flows and data store. This is level 1. From the same reservation, you see, this is what happening the inside entities, that is internal data. So passenger inquiry, first it will inquire whether there is a seat available or not, train available or not, and with what timing it is available. Process for reservation, then reservation storage will control. Here, ticket generation process will be there and report to admin. So reservation process, then it will report to admin. Inquiry, it will be going to reservation process as well as storage and down storage. Okay, this is how level 1 DFD diagram is shows internal data flows and data store. Next, our level 2 and beyond. Okay, further decomposes level 1. Level 1 sub-processes. It will decompose the level 1 sub-processes. More internal detail will come in the level 2 and beyond for a detailed view of specific functional areas. Okay, useful for large or complex systems requiring deeper analysis. So here in this diagram, the same reservation process, you see here is the passenger and where is the admin. Admin You see here reservation process. After query access, what happened? Reservation report and inquiry. This is still there before also. Railway department, reservation, waiting table, cancel table, generate report. This all will come in the railway department, and reservation process will go. When the reservation process will go to railway department, and searching also will go from reservation process, reservation, then confirmation process, waiting process again. It will go in ticket generation process. Then it might be cancel ticket. It might also come in the ticket generation process and ticket generate ticket. This is the process deeper analysis of the DFD level 1. Now, let us know about data dictionary. What is data dictionary? A data dictionary is a centralized repository. Centralized repository of data definitions. Okay. Contents, data name, description, type, size. It will be data repository. Means overall. Like if we take an example, here you see student ID, integer, it will come and unique identifier. So student ID is taken as an integer and it will be taken as a unique identifier. We do, as a faculty, I'm saying, like we don't know if it is more than 2000 students, suppose, then we will not able to remember the names of the students. So how do we remember them? Supposing a 60 number of student in one class, if we won't be familiar to everyone's name. So with the roll number, with the ID, we will identify the student. Next, decision tree. What is decision tree? Decision tree is a graphical tools used to represent decision logic. Okay. And what it uses here? Complex decision making and condition based action. Okay, decision tree example like loan approval. If income greater than limit, then approve, else reject. Suppose your income is not less than limit, then definitely the loan won't be approved. If your income is more than the limit, suppose you are taking 4 lakh loan, but your income is 6 lakh, then definitely you will be approved for loan. And if it is less than 6 lakh, suppose your income is 4, loan is taking 4 lakh and your income is only 2 lakh, then it might be a chances that it will get rejected. This is how the decision tree function. Next, structure English. What is structure English? A method of writing logical step using simple English statement. Keywords like if, then, else, do, while. These are the keywords which we'll be using for structure English. Example, if mark is greater than equal to 40. This is greater than equal to symbol. Okay. If mark is greater than equal to 40, then pass, else fail. If your mark is less than 40, then definitely you will fail in exam. This is how the structure English will work. Next, moving to our unit 13, feasibility study in system development. Definition, let us know the definition. A feasibility study evaluates whether a system is practical and viable. Types of feasibility: economic, technical, behavioral, system performance. Next, economic feasibility definition. What is economic feasibility definition? What's the difference between a feasibility study and economic feasibility study? Here we will know. So evaluate cost versus benefit, but in the feasibility study, evaluates whether a system is practical and viable. Okay, example, cost equal to 1 lakh, benefit how much? 3 lakh, then it's feasible. If it is cost is 1 lakh and if benefit is 3 lakh, then it's feasible. If your cost is 2 lakh and your benefit is 1, then not feasible. It should be, benefit will be must be always greater than cost. So in next, technical feasibility. We have known feasibility study. Under feasibility study, we have known feasibility, economic feasibility study. There technical feasibility. Okay, what is it? Checks whether technology and resources are available. Example, require software, hardware availability. Behavioral feasibility. Again, next is behavioral feasibility. Measure user acceptance of the system. Measure user acceptance of the system. Example, employees willing to use new software. Unit 13, again, continuing technical feasibility, system performance feasibility. Okay, evaluate system speed, reliability, and response time. Steps in feasibility analysis. What are the steps in feasibility analysis? Whether economic, whether technical, or whether system performance. So, primarily investigation, identify alternatives, evaluate feasibility, type, cost benefits analysis, and final decision. Next, moving to our unit 14, input, output, and forms design. Input design definition. What is input design? Designing method to capture accurate data into the system. Then what is the goal of input data? Accuracy, simplicity, efficiency. These are the goals for input data. An input design example will be online form for student registration and validation like name, age, and email must be there in input design. Next, CRT screen design. What is this CRT screen design? The full form of CRT is cathode ray tube, designing screen interface for user interaction. Like features will be clear layout, easy navigation. Like we see in our TV screen, mobile screen, they all use this CRT screen. So this is the figure of cathode ray tube CRT. Like you see, this is pulse is the control grid where the heater, this is the cathode electron beam that will direct the flow of the view. Okay. Next, this one is anode. These two are anode, these three anode, these two here, this side rectangular shape will be diffracting coils. And this one is focusing coil. So this is how it will focus the, like we see in the TV screen, then this is our fluorescent screen where the display will be made. Okay, this is how our screen works. Next, output design. Output design definition. Let us know the output design definition. Designing how results are presented to user. Okay, types, report, screen, like we have seen in TV or phone screen, printed output. These are the output design. Output design example, student result report, like your mark sheet. That is also output design. Bank statement, that is also our output design. Next is our forms design. Form design is input output. It can be input and it can be output. Like in Google form. If we take the example, we can say Google form for data collection. So requirement, what should be in the form? Clarity must be there, simplicity must be there, and proper layout. This is one of the examples for form design for data collection. Like you can see, first name, last name, email. Your email address will be your username. So whenever you log in, you must be using your email ID as a username. So retype to confirm, no? So this retype and your addresses, contact information, account information, personal information like date of birth, gender, like that. The form should be well maintained, proper in proper layout, and it should be simple and clear to the person who will be filling out this form. Next, moving towards our unit 15, hardware, software selection and maintenance. This is the short form I wrote for hardware, H/W, and software is S/W. Okay, in computer industry refers to companies producing hardware. Example, like computer server. These are the under computer industry of hardware system. In software industry, produces application and system software which we are using in our daily basis, like application in our phone, like Swiggy, Zomato for food, ordering purposes, and some learning like learning applications, tutorials point like that. It will be software application. Example, operating system and application. Okay. Procedure of for hardware software selection will be identify requirements, evaluate alternatives, compare cost and performance. Okay. Select best option. This will be the procedure for hardware software selection. Next is major phases in selection. What are the major phase? Requirement analysis, vendor evaluation, which vendor is giving with the low cost and how they are providing, how is their service, that one we have to check. Testing and final selection will be done based on this thing. Criteria for software selection. Cost we have to see, compatibility, whether it's compatible with this, the hardware we have, reliability, whether we can rely on this software, and user friendliness must be there definitely. And use computer, buying second hand system. This will be use computer means what? Buying second hand system. And advantage will be for buying the used computer, low cost, but disadvantage. What is the disadvantage of buying used computer? Risk of failure. So if it is a second hand, there might be a reason someone selling it. No, there is always a reason when we sell our product as a second hand. So might be it's not working. Maybe the person it's not liking it that much. That's why they're selling it in a second hand. So computer contract is agreement between buyer and the vendor, which includes cost, warranty, and maintenance. Whenever you do the contract in computer, what we have to include is cost, warranty, and management. Next, moving towards our unit 16, system maintenance and evolution. Definition, process of modifying and updating software after deployment. Types of maintenance, corrective, adaptive, perfective, and preventive. This is always you have to see when you are maintaining the system. Okay. Maintenance strategy, regular updates, bug fixing, performance improvement should be your maintenance strategy in daily routine. So any doubts so far? Any doubt? So moving towards our next slide, software evolution. Right? Software evolution means continuous improvement of software over time. That can be version control definition, like managing different version of software. Example, version 1 to version 2. And change management. What is change management? Handling changes in system requirement like emerging trend, cloud computing, AI integration, or maybe automation. Okay. Next, moving to agile methodology. What is agile methodology? It's a flexible approach to software development using iterative cycles. What are the features of Agile methodology? Continuous feedback, first development. Agile example will be weekly updates, client feedback after each phase. Like you can see here in this framework of Agile methodology, first we'll plan, then design, then after design where it will go develop, then test, then deploy, then review, then launch. Okay, so this is the cycle, it will go on from here. So there will be a feedback section after every each phase. Like after designing there will be a feedback session from the client whether they like this design, so that we can move to the further phase like development. Then after development they will again show, then test and deploy, review, then when the customer is satisfied and will launch it. Then even there after launching it, if they find any problems or matter of improvement, then they'll go for the version, like version 1 to version 2. In this way, the software evolution will be done. These are the self-assessment questions. This is the end of our class for system analysis and design and for second semester BCA. Course code CSB 1211, self-assessment questions. And these are first questions, define data flow and this is main component. Please I request to go through the SLM for your further understanding. Here what in this slides, in this lecture, we have we try to complete whichever topic is important. So please go through with your SLM thoroughly to understand more. Don't just rely on the lecture, and you can go for YouTube videos as well for better understanding, some tutorial sites like that. What is a data dictionary? Give example, define feasibility study and name its different type. This we have already taken note. What is economic feasibility? Also we have to explain input and design and why it is important. Also we have to explain this. Any 4 criteria for software selection. Also we have done in the class. What is system maintenance? Name its different type. Also we have seen in the class. So thank you. For any further inquiry or like topic related discussion, you can email in this email ID. Thank you. So see you in the next class. At 10. Now it's 10:51. So we'll move like 11:10. We'll see you. We'll start the class at 11:10. Thank you.